All right, so let's get right into it. Back in the 1920s, you had one silent film star who was making everybody cry and another who was making everybody think. We're talking about the hidden genius of one of the great stone face himself, Buster Keaton. So in the silent era, the world really had two kings of comedy. You had Charlie Chaplin, the little tramp, who was an absolute master at tugging at your heartstrings. You felt for him. But then there was Keaton. And Keaton wasn't really interested in your heartstrings. He was way more focused on physics, engineering his gags with the precision of a master mechanic. And to really get what made him so uniquely brilliant, we need to dive into this idea we're calling the geometry of Keaton. This is the whole key. It's how he took what could have been simple slapstick and turned it into this sophisticated science of movement, all built on his obsession with lines, circles, and some pretty terrifyingly complex engineering. So, to make our case, we're going to break his whole method down into three parts. First up, the geometry of the gag. Then we'll look at the actor as an engineer. And finally, we'll get into the philosophy of being the constant in chaos. Okay, part one, the geometry of the gag. Let's really look at how Keaton saw the movie screen. For him, it wasn't a stage. It was more like a mathematical grid, a playground for physics. See, for Keaton, the funny part wasn't in his face, because, he famously had no expression. The humor was in the perfect, calculated path of his body moving in relation to something else, a falling building, a speeding train, whatever. A gag wasn't just a joke, it was a geometric problem that he had to solve. And he approached these problems with this really clear three-step process. First, you isolate the variables, the falling boulder and where it's going to go. Second, you calculate the trajectory for both himself and for the object. And third, you execute it all with the precision of a machine. This created something he actually called mathematical suspense, where the audience is just holding its breath, waiting for the equation to perfectly resolve itself. So now let's see how that geometric thinking builds up into stunts that required not just an actor, but really the mind of an engineer. His most famous stunt, you've probably seen it. It's from the film Steamboat Bill Jr., and it involved a level of real-world physical engineering that is it's still terrifying to watch today. And let me be perfectly clear about this. This was not a special effect. It was real. 2 tons. That was the actual real-life weight of the building facade that was built to fall directly on top of him. A solid 2-ton wall falling with the full force of gravity. And this was his margin of error. Just 2 inches of clearance on each side of his shoulders as that window came down around him. If he had been off his mark by even a little bit, if he had shifted his weight, well, he would have been crushed. No question. So here's the crucial point. His survival depended entirely on a single, unwavering mathematical certainty. This wasn't just an act of being brave. It was an act of total, absolute trust in measurement, in physics, and in gravity. And that belief in physical systems wasn't just for one death-defying stunt. It was his whole approach to making movies. He basically treated the entire set like a giant interactive Rube Goldberg machine. In his film, The General, he didn't use a little model. He used a real 160-ton locomotive as a prop because he understood how to use its massive weight and leverage to create a punchline on a scale nobody had ever even dreamed of. But this whole obsession with mechanics and physics, it all leads back to the one question that defined his entire career. With all this insane chaos happening around him, why did he never, ever crack a smile? Well, the answer is actually pretty simple. If he had smiled, or looked scared, or even just winced, the whole perfect geometric precision of the gag would have just fallen apart. He would have just become another person reacting to danger. And the stunt would have lost all of its cold, mathematical beauty. So philosophically, his stone face makes him the one constant in a completely chaotic universe. Think about it. Everything around him is a swirling, unpredictable mess of curves and crashes. But Keaton, he remains a perfect, stable, vertical line right in the middle of it all. He's the fixed point. And this creates what you could call the Keaton effect. Because his face is a total blank canvas, we, the audience, we're the ones who project all the emotion onto the movement itself. We're not laughing because he's being funny. We're laughing because the situation, the physical equation he just solved, is so perfectly and often terrifyingly executed. So what's the big takeaway here? Why does Buster Keaton's 100-year-old approach to comedy still matter so much today? What Keaton really left us with was a whole new language for comedy. He proved that it didn't just have to be silly or sentimental, it could be calculated. He brought the mind of an engineer to the art of being a clown, and he fused them into something totally revolutionary. He showed us that the screen is a grid, a gag is a problem, and that sometimes the deepest emotion isn't in a smile, but in the pure, precise poetry of movement. And that legacy of precision, it's everywhere now. Think about Jackie Chan using his entire environment like a weapon and a jungle gym. That is pure Keaton. Or think about the mind-bending, real-world stunts in a Mission Impossible movie, where the thrill comes from knowing it's real physics at play. So the next time you watch a big, complex action sequence, look past all the explosions for a second and look for the ghost of Buster Keaton. I promise you, he's in there, hiding in the geometry.